Very good evening, my dear students.
Good evening, sir.
Good evening,
Good
beta.
evening, sir.
Students, we started the new chapter polynomials from your mathematics textbook. And in the last class, we learnt about the definition of a polynomial, wherein in detail we understood what is the meaning of a polynomial and the exact explanation for the definition of polynomial. Am I right, beta?
Yes,
Today,
sir.
we are going to continue the same chapter polynomial with the next concept. And the concept dealt will be degree of polynomial and classification of polynomials. Is that clear, beta?
Yes,
Yes,
sir.
sir.
Okay, students, all of you write on the side heading degree of a polynomial. I repeat, degree of a polynomial. Students, it is not a new concept for you people. Already in 8th standard, you studied the same. Am I correct?
Yes, sir.
Yeah. Beta, can anybody tell, according to you, what do you mean by degree of a polynomial? Any answers, beta, from your side? Quick. Whatever you know about degree of a polynomial. Any answers? Yeah. Pratibha, any idea, beta, from your side? What is a degree of a polynomial?
Sir, the highest exponents of what variable, sir, one variable.
Very good, beta. Jia, any answer from your side?
The highest degree of a monomial. Uh,
Okay. Anybody else want to try? Okay, beta. We'll do one thing. First, I'll give you the sentence, write down the definition, and then I will explain with the proper example. Okay, beta? Make a pair. Write down. The highest, the highest power or exponent. The highest power or exponent of a variable in the given polynomial is called as degree of polynomial. Students, write down the definition properly. I'll explain the meaning with the help of certain examples. Okay.
okay, sir.
Yeah. Beta Shreya, will you repeat the sentence what I have written on the board? Quick.
Yes, sir. The highest power exponent of a variable in the given polynomial is called as degree of polynomial.
Very good, beta. So look at the meaning. It is very simple, beta. You have to write one polynomial first. Question comes, what is a polynomial? In the last class, we discussed, beta, an algebraic expression in which the powers or exponents of each and every variable should be a whole number. Am I right?
So,
Yeah.
Yes, sir.
Once you write
Yes,
the
sir.
polynomial, you have to search all the variables and all the exponents. You have to mark the values of the exponents or the powers, which are the whole numbers. Out of that, which is highest has to be considered as the degree of a polynomial. Is it clear to everyone, beta?
yes, sir. 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 Yes, sir.
Yes, sir. Yes,
Let us
sir.
see some examples. Examples. Don't write beta. Let me finish off first. Don't write, observe. I'll write few examples. 2x plus 5. Here beta, how many variables are involved?
Only one variable.
Only one. That is
One.
x. What's the power beta of x?
One, sir.
One, sir.
1. So its a degree beta. Its a degree is 1. What the concept?
Yes, sir.
Because there is no other variable available with the power which is more than 1. I think you understood the concept. Yes, beta?
Yes, sir.
Let me write one more. Minus 13 m square plus 2m minus 3. Here, how many variables are there, beta?
Sir, one only, sir. M two times. One.
Yeah, beta.
One.
Here also one variable, but it is repeating twice, beta. Here also and here also. Look at the powers in both the cases. Here the power is 2 and here the power is 1. Am I right, beta?
Sir.
Now, out of these two, which is highest? 1 is highest or 2 is highest?
Two is
Two, sir.
highest.
2 is highest. So, we call its degree as 2. Is it understood, beta?
Yes, sir.
Let me take one more example, beta. All of you observe one more example. I'll write 14 p raised to 4 minus 21 p square plus 2 by 3 p minus 7 p to the power 8. Students, look at the concept. I have written one polynomial 14 p to the power 4 minus 21 p square plus 2 by 3 into p minus 7 p to the power 8. Am I right, beta?
Yes, sir.
Basically, it is a polynomial. The reason every variable is having the exponent which is a whole number. Here it is 8, here nothing is there means 1, here it is 2,
One.
here it is 4. Now beta, what is the highest power among all? Can anybody tell?
So,
Eight.
8. Look at this. 1, 2, 4 and 8. The highest one is 8. Hence, what is the degree beta?
Degree is eight, sir.
Degree is 8. So, by these examples, we can understand what we are supposed to do. Every polynomial, we have to look how many powers are there for the variables. Basically, first, how many variables are there? Maybe one, maybe two. Sometimes one variable is only repeating. Everywhere, you need to check with the powers, the exponents of the variable. Among that, the highest one will be considered as a degree. Is there any questions, beta?
No, sir.
Okay. Any issues? Any questions?
No, sir.
Yeah, but write on the examples fast, quick. You can take a screenshot also.
Yes, sir. Over.
yes, sir,
Done,
completed.
but
Yes, sir.
okay. Shall I erase beta?
Yes, sir.
Yes.
Fine. Okay, students. Now we will move to the next concept of the chapter. What is the concept, students?
Classifications of polynomials, sir.
Yeah, you are correct. We are going to deal with classifications
Of
of
polynomial.
polynomials. Right on the side heading. Classification of polynomials. Okay, just write the side heading. I will explain the concept. Then we will go for the notes. Okay.
Okay,
Okay,
sir.
sir.
Now, beta, all the polynomials have been classified based on two categories, based on two aspects. How many aspects, beta?
2, sir.
2, sir.
Two. Now, question comes, what are those? Beta, number one, based on the number of terms. What is the first one?
Based on number of terms.
Based on a number of terms.
Yeah. And the second one is based on the degree of a polynomial. What is the second one?
Based on degree of a
Based on a
polynomial.
degree of a polynomial.
Yeah, beta. Now, the based on number of terms, what are the types of polynomials? And based on degree of a polynomial, what are the types of polynomials? We will discuss in detail one by one. Is that clear?
Okay, sir.
Yes,
So, beta,
Okay, sir.
first, write down, beta. Make a para. Take down one sentence. Polynomials are classified on the basis of two different aspects. Two different aspects. As explained below. Students, copy this sentence. Polynomials are classified on the basis of two different aspects as explained below. Now write the side heading, beta. Roman letter 1. Make a circle. Roman letter 1. Based on number of terms. Is that clear?
Yes, sir.
Yes.
Yeah. Write down, beta, fast. We'll start with the classification. Wait.
Yes, sir.
Written?
Yes, sir.
No, beta, it is nothing new for you people. Even right from 6th standard and 7th standard, you have learnt this particular concept. If only one term is there in the polynomial, what we call that? If two terms are there, what we call the polynomial as?
Binomial,
Three terms are there,
trinomial.
what we call the polynomial as? Okay, beta. Who will tell the types of polynomials based on the number of terms? Quick.
Monomial,
I will
binomial,
take
monomial, binomial.
Yeah,
Monomial
one
containing
the
one.
Monomial consists one
Yeah, beta. 1 minute, 1 minute. I'll go to Netra. Yeah, beta.
A polynomial containing one term is called monomial.
Yeah. Next one.
Binomials. A
Yeah.
polynomial having two terms is called
Is okay. Shreya, what is the next one, beta?
binomial.
Shreya.
trinomial, sir.
Yeah. Define it, beta. Sentence.
The polynomial which has three terms, sir.
Okay, beta. You people already know it. We will write the same one in proper manner. Okay. So write down, beta. Below this, number one, monomial. Number one, monomials. What does it mean? Write down. A polynomial having only one term. Only one term is called as monomial. Below, write the example, beta. Examples. We'll go to 2 to 3 examples. Number one, very simple. I'm going to make it 2x. Okay. Next, minus 5m square divided by 7. Minus 5m square divided by 7. Let me write one more. 13 x square y, etc.
13 into C.
13 x square y, etc. Okay, beta, look at the examples here. If you see, it is only one term. You can see 2 and x are there, but they are associated with multiplication sign. So we call it as a one term. Now coming to this beta, minus 5 is there, 7 is there, m square is there. All are associated with multiplication and division. Hence it becomes a single term. Is that clear?
Yes, sir.
Yes, sir.
Now, here beta, you can see 13, there are two variable, x also and y also. X is repeating twice, y is repeating only once. Even though these many terms are involved here, we call it as a monomial because the operation used in between is multiplication. Is that clear beta?
Yes, sir.
Yes, sir.
Okay, let us go further. We will go for number 2, that is binomial. Am I right beta?
Yes, sir.
Yes, sir.
Okay, right now. Second one, binomials. But look at the sentence. Sentence remains same, only a bit of change. A polynomial having exactly two terms is called as binomial. Right on. A polynomial having exactly two terms is called as binomial. We'll take some examples better. Number 1, I'll make it as much as simple. M plus 7. This is the first one. Let us go for the other. Minus 13 y square plus 2y. Let me write one more example wherein we have to get two terms. Okay, exactly. 2 by 3 t to the power 8 minus 17. Right, etc. Copy beta, quick. Written.
Yes, sir.
Yes, sir.
Now, students, observe carefully. You will understand the meaning of two terms. M is 1, 7 is 1. In between addition is there beta. So it is going to create two terms. But if you write 7m, it becomes only one term. It becomes the example for monomial. When you write the addition in between, it becomes binomial. Is that clear beta?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Again, you can see here minus 3 is involved with y square and 2 is involved with y. This is one term separately. This is one term separately. Both have been added. So it becomes the two terms nothing but binomial. Is that clear, beta?
Yes, sir.
Yes, sir.
Yes,
In
sir.
the last example, this entire thing is one term and this is the other term. Again, you are going to have two terms and they are attached with the subtraction. Got the concept?
Yes, sir.
Yes, sir.
So, beta, here one thing to be noted: whenever multiplication and division takes place, it is going to give you the same term, the single term. The moment you get the subtraction and the addition in between the terms, they are going to make the partition of the terms. Is that clear, beta?
Yes, sir.
Okay.
Yes, sir.
Let us go for let us go
Yes,
for
sir.
one more type of polynomial based on the number of types. What is that number of terms? What is that, beta?
Trinomial.
Trinomial.
Binomials.
Right down.
Trinomial.
Yeah. A polynomial having exactly how many terms, beta?
3 terms, sir.
3 terms of.
3 terms, sir.
Yeah, exactly 3 terms is called as trinomial. Let us write some examples. Examples. Number 1, 3x squared minus 2x plus 1. This is one example. Let me take few more. 2 by 7 m to the power 6 minus 2m squared plus 13. This is the second example. Let me take one more. 4p raised to 5 minus 17 q raised to 4 plus 13r, etc. Write down, beta, quick. Written?
Completed, sir.
Yeah. Look at the concept, beta.
Yes.
This is one term, this is second term, and this is third term. Minus and plus are involved, so it is a trinomial. Then again, you can see this entire thing is one term. This is the second, and this is the third term. Again, minus and plus have been involved. It creates a trinomial. Coming to this, you can see one term. This is the second, and this is the third, associated with plus and minus. So it creates a trinomial. Is there any doubts, beta?
No, sir.
So in simple word, if a polynomial is having only one term, we call it as a monomial. If there are two terms in the polynomial, we call it as a binomial.
Binomial.
If there are three terms in the polynomial, we call it as what, beta?
Trinomial.
No, question comes, sir, if there are four terms, what we have to call? If there are five terms, what we have to call? If there are six terms, if there are 100 terms, what will be the name of the polynomial? Am I correct, beta? Students, remember, as the number of term increases, if you keep on naming them, you have to keep on naming only. Understanding?
Yes, sir.
Yeah.
Yes, sir.
So, if the terms are four or more than four, maybe five, maybe 100, maybe 200, in such cases, the polynomials are referred as just the polynomials. There is no special name involved. Is that clear, beta?
Yes, sir.
So below, write down the side heading note. Right? Note. If the polynomial, if the polynomials are having four or more than four or more than four terms, then they are called as polynomials only. There is no special name, beta. Generally, polynomials only will be addressed. Got the concept?
Yes, sir.
Yes,
Yeah. Write it down. Or
yes, sir.
okay.
Sir.
Now, students, we will go for the second category of the classification. What is that?
Degree. Degree.
Yeah, beta. What is that?
So based on degree of a polynomial.
Yeah, beta. Write down number second. Roman letter 2, n circle. Based on degree of polynomial. But look at the concept. In the earlier classification, we concentrated on the number of terms. How many terms are there? But now, in this classification, we will not think about number of terms. The number of terms may be anything. We will concentrate on the degree of the polynomial. Understanding?
Yes, sir.
Okay,
Now
sir.
question
Yes, sir.
comes, what is the degree? Beta, just now we have done in the beginning of today's session. The highest power or exponent of the variable
Exponent in
present
the
in the
variable.
polynomial
The
is nothing but
variable.
degree of the polynomial. Correct, beta?
Yes, sir.
Now,
Sir.
there are three types again, beta, for your syllabus. The first one, we call it as linear polynomial. If the degree of the polynomial is 1, then we call it as linear polynomial. If the degree of the polynomial is 2, we call it as quadratic polynomial. What we call, beta?
Quadratic.
Yeah.
Quadratic
Quadratic
Meaning,
polynomial.
if the
polynomial.
degree is 3, beta, if the degree is 3, we call it as cubic polynomial.
Cubic.
Is it clear?
Yes, sir.
Yes, sir.
Okay, let's write the same in detail properly. Write down below number 1, linear polynomial.
Linear polynomial.
Netra, make yourself new. A polynomial of degree 1 is called as linear polynomial. Example, I'll write 5y. This is 1. Then I'll write minus 7m plus 3. Let me write one more. 13 by 8 p minus 21, etc. Better copy fast. 5y, comma, minus 7m plus 3, comma, 13 by 8 into p minus 21. Students, you can see here the number of terms are not going to be important. Here it is only one term, here it is two term, again it is two term. What matters is the degree. Look at this, beta. The highest power is 1 here. Here also there is only one variable with the power 1. Here also one variable with the power 1. Everywhere the highest power of the variable is 1. Hence we call these polynomials are possessing degree 1. So the special name given is linear polynomial. Got the concept?
Yes, sir.
Yeah. Any confusions, beta?
No, sir.
Yeah.
Sir.
Right
No,
below.
sir.
Yeah. Number 2. What is the second type, beta?
Quadratic polynomial.
Yeah. Right. Quadratic polynomial. Take down the definition, beta. A polynomial of degree. How much, beta?
2, sir.
2, sir.
2 is called as quadratic polynomial. Write down fast. Take down below. Examples. We will write few examples, beta. Let me write 53 m square. This is the first example. Then minus 218 x square plus 12x plus 1. Minus 218 x square plus 12x plus 1. Let me write one more. Y square plus 3, etc. Copy beta, etc. Students, here, observe the examples written. In this case, only one variable with the power 2. The maximum power is 2. That is the degree is 2. Then here, beta, the variable is only one but repeating twice with power 1 with power 2. The highest one is 2, so its degree is 2. Am I right? Here, again the variable is only 1 with the power 2, which itself is the highest number. So these all three are called as quadratic polynomial. Is that clear, beta?
Yes, sir.
Yes, sir.
Beta, one thing to be noted, it may be having single term, it may be having two terms, it may be having three terms. We are not going to bother about the number of terms. Everywhere, what is going to matter, beta? The highest power. Is that clear?
Yes, sir.
Okay, copy fast. Now, one more. What is the third one, beta?
Cubic polynomial.
Cubic polynomial. I'll make the changes in the statement here only. Cubic polynomial. A polynomial of degree, what beta?
3,
Three,
sir.
sir.
Is called as what?
Cubic polynomial. Cubic
Now,
polynomial.
let's take some examples, beta, for the same. Let me write one simple example. X to the power 3. It is a polynomial wherein only one variable is there with the highest power 3. Okay, beta? Then 2 m cube plus 5. This is the second example. Let me go to one more example. 53 m to the power 3. Better, but I'll take the different variable y. I'll take y cube minus 12y square plus 13. Second example. Let me write one more example. 43 p to the power 3 minus 112 p square minus 12p plus 18, etc. Copy, students.
Over, sir.
Over, sir.
Written. Any confusions, beta?
No, sir.
No, sir.
Look at the concept here. The highest power is 3, as I said earlier. But here also only one variable with the highest power 3. Here only one variable repeating twice with power 2 also with power 3 also. The highest is 3, hence its degree is 3. We call it as a cubic polynomial. Is that clear?
Yes, sir.
Yes, sir.
The last one, he is repeating 3 times with power 1, power 2 and power 3. Since the highest one is 3, its degree will be referred as 3 and it will be called as cubic polynomial. Is that clear, beta?
Yes, sir.
Yes, sir.
Friends, tell me any confusions you people are having here?
No,
No,
sir.
sir.
Beta, let me repeat the classification of polynomial. Students, as I said, the polynomials are classified based on two categories. Number one, based on the number of terms involved in the polynomial. Number two, based on the degree of a particular polynomial. In the first case, we have three varieties: monomial, binomial, trinomial. Similarly, in the second case also, we have three varieties: linear, quadratic, and cubic. Is that clear, beta?
Yes, sir.
Students, for your syllabus, you have only three: linear, quadratic, and cubic. But when you will go to 11th standard, beta, you are going to hear one more type that is called as biquadratic. What we call, beta?
Biquadratic.
The degree of the polynomial will be exactly 4. Got the concept?
Yes,
Yes,
sir.
sir.
Anyhow, not required for your syllabus. Clear, beta? Now again, the question comes, sir, if the power is 4, the degree is 4, what we call? If the degree is 5, what we call? If the degree of the polynomial is 7, what we call it as? Am I right, beta?
Yes, sir.
Yes. Yes.
Yeah.
Yes, sir.
Again, write down the note. Side heading. Write down the note. Just 1 minute, beta. Yeah. Students, if the degree of the polynomial is 4 or more than 4, beta, we call them as polynomials only. Is that clear?
Yes, sir.
Yeah, right.
Yes, sir.
The polynomials of degree 4 or more are referred as polynomials only. There is no special name, beta. Okay? But when you will go to 11th standard, beta, you are going to hear about biquadratic polynomials whose degree is exactly 4. Is that clear, beta?
Yes, sir. Yes, sir.
At present, in 9, you have to read 4 or more than 4 degree as polynomials only. Clear, beta?
Yes, sir. Yes, sir.
Okay. Beta, under the classification, if you see the syllabus, what is the next concept? Look at that.
Sir,
Our
exercise 2.1.
Yeah, beta. After this, we are going to deal with exercise 2.1. Correct, beta?
Yes, sir. Yes, sir.
But before that,
Yes, sir.
there is one more concept to be addressed to you people. That is constant polynomials and zero polynomials. What, beta?
Constant
Polynomial and zero
polynomials
polynomial.
and zero polynomial.
Yeah, beta. So write down the side heading. Constant polynomials and zero polynomials. Students, these two are the special varieties of the polynomials, which we are going to discuss apart from category 1 and category 2. Is that clear?
Yes,
Yes,
okay,
sir.
sir.
Yes, sir.
Now, question comes, what is constant polynomial first? Beta, whenever we write only the numerical values, I repeat, whenever we write only the numerical values, we call them as constant polynomials. Is that clear?
Yes, sir.
So, for example, beta, if I write the number 5, it is called as constant polynomial. If I write a number minus 18, it is also constant polynomial. Say for example, I have written 151 divided by 9. It is also a constant polynomial. Are you getting the concept?
Yes, sir.
Yeah. Beta, if you see, actually these are the pure numbers. Am I right? According to the definition of polynomial is basically algebraic expression. It means there will be a mixture of number with the variable. Am I correct, beta? So we will get a confusion. So if there is no variable involved, how we are going to call it as a polynomial? Am I correct?
Yes,
Yes,
sir.
sir.
This is the answer for this. This 5 can be written as 5 into x to the power 0. Am I correct?
Yes, sir.
This
Sir.
minus 18 can be written as minus 18
Minus
x to the
18
power
x
0. Any
to
variable you can take, whichever you want. Beta, make yourself mute. Okay. This can be written as 151 divided by 9. You take whatever the variable, beta. Here I'm going to take p to the power 0. Students, in the laws of exponents, we have learned a power 0 is 1. Any number to the power 0 is always 1. It is going to become 1. 1 into 5 is 5. It is going to become 1. 1 into minus 18 is minus 18. It is going to become 1. 1 into this is this. Got the concept?
yes.
Yes,
It
sir.
is about the constant polynomial. Beta, make a para. I will dictate a line. Write down. The
Yes, sir.
numerical values written without any variables. The numerical values written without any variables are referred as are referred as constant polynomials. Right below examples. Better copy the same in the same manner. First write 5, show it like this. Write minus 18, show it like this, and this like this. Copy fast. Quick. Students
Completed,
written.
sir.
Yeah. Students write below note the degree of any constant polynomial. Any constant polynomial is. Can anybody guess better what will be the degree of the constant polynomial from the above example? It is
Zero.
given
0.
1.
0.
0.
0.
0.
0. Look at this. Everywhere the variable is having only one power with it, that is 0, which is the highest itself. So we call it as 0 is the degree. Got the concept better?
Yes, sir.
Yes, sir.
Write down fast. Write down fast. Done?
Yes, sir. Yes, sir.
Beta, now make one more para wherein we will talk about zero polynomial. Okay, beta? Now question comes, what is this zero polynomial? Students understand, it is very simple. A number 0 written without any variable is called as zero polynomial. Getting the concept?
Yes, sir.
Yes, sir.
Example is 0 itself, beta. It means whenever you take the whole number 0, you can call it as zero polynomial. Understanding, beta?
Yes, sir.
Now
Yes,
again,
sir.
we can raise
Yes.
a question. Polynomial means variable should be present. Here there is no variable. What we can do, beta? This 0 can be written as 0 into x to the power 0. Getting my point? The same 0, beta.
Yes,
The
sir.
same 0 can be written as 0 into x to the power 1. It can also be written as 0 into x to the power 2. Are you getting my point, beta?
Yes, sir. Yes, sir.
Yes, sir.
Also be written as 0 into x to the power any number, beta. It may be 5, it may be 8, it may be 100, it may be 200, 500, whatever. Understanding? I'll take 17, etc. Are you understanding better what I'm trying to say?
Yes, sir.
Yes, sir.
So what I have done, this I have written in this manner. X to the power 0 is 1. 1 into 0 is 0. Here x to the power 1 is x only, but x into 0 is always 0. Here beta x square, if you multiply 0 with this, it becomes again 0. In simple words, you take any term multiplied with 0 always gives you 0. Understanding beta?
Yes, sir.
This is the exact meaning of the 0 polynomial. Okay? Yeah. Beta, make a para and write down. The number 0 written without any variables is referred as 0 polynomial. Better write example. Take down the same thing whatever I have done. Write 0, show the arrow marks, copy all these things. Quick beta, fast. Write it fast. Below this example, write note. Beta, by looking at this, can you predict what is the degree of 0 polynomial, beta? What is the degree? Is it 0? Is it 1?
0.
Is it 2? Is it 17? What is the degree, beta? Highest power of the variable.
Sir, 0.
0 beta, highest power. 1 is also possible.
17, sir.
70. Beta,
17.
here it is 17. I can write it 100 also. 500 also. 1000. Crores
No,
together I can write.
no, sir.
Yeah. So
Infinite.
what
0
will be
is the highest degree.
No,
0
beta.
is the
0 is the
highest.
smallest number, na? 0 is the smallest number. How you are going to say it as the highest thing? No. Any idea, beta?
Infinite. Infinite.
Yeah, beta. Infinite. We call it as infinity. Students, remember, here the highest power of the variable is just like the tail of Lord Hanuman. We don't know the ending. Are you getting my point?
Yes, sir.
The highest power may be any number which is beyond our imagination also. So we call the degree of 0 polynomial is always infinite. Is that clear, beta? So
Sir.
write down the degree of 0 polynomial. The degree of 0 polynomial is infinite. We don't know exactly. Infinite, not determined. Is that clear, beta?
Yes.
Okay, students. With this, I'm going to end the today's session. Tomorrow, we will continue with exercise 2.3. Is that clear, beta?
Yes, sir.
Okay.
Yes.
So, at the end, beta, what we have studied today? Degree of a polynomial and classification of polynomials, which is based on two aspects, based on number of terms and based on the degree of the polynomial. Then finally, we discussed two special varieties of the polynomial called as constant polynomial and zero polynomial. Okay?
Yes, sir.
Yes,
Yeah.
sir.
With this, beta, I'm ending the session. We will meet tomorrow again at the same time. Is that clear?
Yes, sir.
Yes, sir.
Okay, students. Bye. Take care.
Bye, sir.
Bye, sir.